It was October 19th, 2017. Just another routine day for astronomer Robert Warwick, who was scanning through telescope data like he had countless times before. But on this day, something stood out. Something that made him stop and take a closer look. What he saw didn't just spark curiosity, it changed everything we thought we knew about space. There it was, an object tearing through our solar system at a jaw-dropping speed of 59,000 miles per hour. But here's what made it truly bizarre. It wasn't following the rules. Its path showed no sign of being influenced by the sun's gravity. It wasn't orbiting like a planet or caught like a comet. No, this thing was just passing through. Straight from interstellar space, the deeper scientists dug, the stranger it got. First, they figured out its size, about the length of a football field. But its shape? Nothing like any asteroid or comet we've ever seen. Even weirder, it left no trail, no dust, no gas, no tail. For something so close to the sun, that's unheard of. And speaking of close, that mystery object had actually swung past the sun before we even spotted it, just 23 million miles from the surface. For comparison, Mercury, our closest planet to the sun, doesn't even get that nearby. Then came the real shocker. As it left the sun behind, instead of slowing down, like it should have, it sped up. Fast. It suddenly accelerated to nearly 194,500 miles per hour, 55 miles per second. That kind of boost doesn't just happen on its own. It was as if something gave it a push. Scientists named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. And the name couldn't be more fitting, because everything about it pointed to one unsettling possibility, that this wasn't just some space rock. By the time we noticed it, Oumuamua was already on its way out, speeding toward the edge of the solar system. Today, it's more than 4.3 billion miles away and getting farther every second. The chances of it ever coming back? Zero. Its shape, its behavior, its interstellar origin, none of it made sense. Some scientists started wondering aloud, what if Oumuamua wasn't natural at all? What if it was built? What if it was a probe, a messenger from another civilization? That question sparked something big. Project Lyra, a bold mission aimed at chasing down Oumuamua, catching up to it, and finally answering the question that's haunted scientists ever since. What exactly passed through our solar system that day? As soon as it was discovered, astronomers across the world dropped everything. They turned their telescopes toward the mysterious visitor, hoping to catch one last glimpse before it disappeared into the darkness of deep space. Early estimates suggested it was around 1,300 feet long, but just 130 feet wide, a strange, cigar-like shape no natural object should have. To this day, no one knows for sure what Oumuamua really was. But one thing is clear. It wasn't just another rock in space. It challenged everything we thought we knew, and it left behind one of the greatest mysteries of our time. When scientists first got a good look at the strange object racing through our solar system, they thought it resembled a stretched-out cigar long. Thin, unlike anything they'd seen before in space. But as more data came in, that idea started to shift. Researchers at McMaster University in Canada crunched the numbers and came up with a different picture. According to their calculations, this object could have been around 380 feet long, 364 feet wide, and 62 feet thick. That makes it slightly larger than the Statue of Liberty. But instead of a cigar shape, they suggested something even more unexpected. Maybe it was flat, like a pancake. That's not your typical space rock. In fact, very few natural objects have ever had similar proportions. One rare exception is Arrokoth, a distant body way out in the Kuiper belt, beyond Neptune. But even that doesn't make Oumuamua any less of a cosmic oddball. Its shape still didn't match anything scientists had encountered before. It was unique, and it only got weirder from there. This thing was tearing through space at an astonishing speed, 16 miles per second. That's faster than Voyager 1, the spacecraft we launched in the 70s that's now cruising out of the solar system. To put that in perspective, Oumuamua could fly from New York to San Francisco in just under 3 minutes. At that speed, there was no way it was being held by the sun's gravity. It was just passing through. Naturally, astronomers wanted to know where it came from and what exactly it was. Early on, many assumed it had to be a comet. That would have made sense. Comets are icy, and when they get close to the sun, they heat up. The ice turns into gas, releasing dust and forming a bright, glowing tail. You might remember seeing something like that with Comet Hale-Bopp back in 1997. It was so bright, you could see it with the naked eye. But Oumuamua, nothing. No gas, no dust, no tail, not even a shimmer. It slid past the sun as silently as a shadow. No evaporation, no activity. It didn't behave like any comet we've ever seen. Not just a little dramatically. Roughly 40 days before it was first detected, Oumuamua had flown dangerously close to the sun, just 23 million miles from its surface, closer than Mercury's orbit. And after that close encounter, it suddenly picked up speed. It wasn't just drifting anymore, it was moving with purpose. At its peak, it hit 54 miles per second. That's 3.5 times faster than before its solar flyby. To give you a sense of how crazy that is, it was traveling 5 times faster than Voyager 1, 11 times faster than SpaceX's Starship, and 250 times faster than the speed of sound. Normally, when comets accelerate, it's because jets of gas and dust are blasting off their surface, giving them a little extra push. But Oumuamua didn't have any of that. No tail, no jets, no trace, yet it accelerated. So now the question wasn't just what is it, but what made it move like that? And this is where things took a turn into truly uncharted territory. In 2021, Harvard astronomer Avi Loeb, along with his colleague Shmuel Bialy, proposed a bold theory. What if Oumuamua wasn't just a rock or a comet or even a naturally occurring object? What if instead it was something entirely different? A spacecraft, a possible probe created by an advanced extraterrestrial civilization, maybe not sent directly to us, but drifting through space on a mission we don't understand. A messenger from the stars, perhaps. One that passed through our solar system just long enough to spark the biggest question of all. Are we alone? Back in 2017, when the mysterious object Oumuamua zipped through our solar system, most scientists assumed it was just a weird-looking rock from another star. But 2 researchers, Harvard astronomer Avi Loeb and his colleague Shmuel Bialy, weren't so quick to accept that explanation. They had a bold idea. What if Oumuamua wasn't a natural object at all? What really caught their attention was a strange moment when the object unexpectedly sped up right after its close pass by the sun. Sure, the sun's gravity could give it a slingshot effect. That part makes sense. But here's the thing. The math didn't add up. The acceleration was too strong to be explained by gravity alone. So, Loeb and Bialy offered a wild but scientifically grounded theory. What if Oumuamua was using light sail technology? It sounds like science fiction, but it's actually based on real physics. A light sail is an ultra-thin, lightweight material that can be pushed by light, literally. Photons from the sun, while tiny, can apply a gentle but constant pressure, and over time, that push adds up, accelerating the sail to incredible.
In fact,
We've already tested this kind of tech. In 2010, Japan launched the Icarus spacecraft, the first to successfully use solar radiation for propulsion. It used a light sail to cruise toward Venus, proving the concept works. So, maybe, just maybe, Oumuamua was something similar. A probe equipped with a solar sail built to coast through space and use starlight to change direction as it passed different systems. And if that's true, it might not have just had a sail. It could have included advanced tech we can only guess at: scanners, communication systems, maybe even navigation tools. To test if such a sail could survive the harsh conditions of deep space, Loeb and Bialy ran detailed calculations. They looked at how much damage interstellar gas and dust would cause at those high speeds. The answer? If it really was a solar sail, Oumuamua could have traveled over 16,000 light-years without falling apart. Now, to be clear, Loeb and Bialy aren't claiming they've found an alien spaceship. They're saying it's a real possibility, and one worth taking seriously. After all, if Oumuamua was an artificial object, the light sail idea could be just one piece of the puzzle. It might have been something much more advanced, an unmanned explorer, quietly observing our solar system before vanishing back into the void. And based on everything we've seen so far, it might not have been carrying a crew, but it could still have been carrying a message. Let's put Oumuamua's journey into perspective. At the speed it was moving, about 196,000 miles per hour, it would take roughly 11,000 to 11,500 years to travel just one light year. Now, the closest star to us, Proxima Centauri, is a little over 4 light years away. That means, if Oumuamua came from that direction, the trip would have taken somewhere between 44,000 and 46,000 years. That's not a weekend road trip. So if this object was a spacecraft, there's almost no chance it had living passengers aboard. No life form we know of could survive a journey that long. It would have to be unmanned, either remotely controlled or run by some kind of onboard AI. But not everyone's buying the alien probe theory. Many scientists think it's jumping to conclusions. Sure, Oumuamua is weird, but extraordinary claims need extraordinary proof, and in their view, there just isn't enough solid evidence yet. So, they've come up with other ideas. Two astrophysicists, Alan Jackson and Steve Desch, from Arizona State University, think Oumuamua might be something much less exotic, though still fascinating. Their theory? It's a chunk of frozen nitrogen. We've seen this kind of stuff before. When NASA's New Horizons flew past Pluto in 2015, it spotted
as it got close to the Sun,
the heat would have caused the nitrogen to slowly vaporize, creating a gentle push, kind of like natural jet propulsion. That could explain Oumuamua's sudden acceleration, without the need for alien tech. But there's more. Daryl Seligman from Cornell and Jennifer Bergner from UC Berkeley have their own theory. They think Oumuamua started off as a plain old comet, rich in water ice, just orbiting some distant star, but at some point it got flung into interstellar space. On its long journey, it was bombarded by cosmic rays, high-energy radiation from exploding stars. Those rays could have transformed a good chunk of its water ice into hydrogen gas, which stayed trapped inside the frozen structure. When Oumuamua finally reached our Sun and began to heat up, that gas started to leak out in tiny jets, giving the object a boost without creating a visible tail. In other words, no flashy comet tail, but still enough propulsion to alter its course. Others suggest even simpler explanations. Karen Meach, an astrophysicist at the University of Hawaii, believes Oumuamua might just be a regular comet, just one that doesn't carry much dust. Without dust, there's no tail. Simple as that. And what about that strange shape? Sure, it looked like a cigar or maybe a flat pancake depending on who you ask, but who's to say that's rare? The universe is massive and full of things we've never seen. The reason it seems unusual to us might just be because we haven't looked at enough of these objects up close yet. Odd shapes could be way more common than we think. They're just too far away to spot. In the end, most scientists agree on this. Oumuamua was probably a natural object, maybe an asteroid, maybe a comet, or maybe a fragment of something much older and colder from another star system. But here's the thing, we still don't know for sure, and that one unanswered question, that possibility, however slim, that it might not have been natural, that's what keeps everyone's imagination alive. The idea of launching a mission to chase it down? Incredible, but also incredibly difficult. Oumuamua is now billions of miles away. It's tiny, less than 3.5 times shorter than the Empire State Building and speeding out of the solar system. Trying to spot it now would be like standing on the beach in San Francisco and trying to see Sydney, Australia, with a pair of cheap binoculars. And yet, the mystery remains. What really passed by Earth that October day in 2017? Was it just a cosmic rock or something much, much more? When the interstellar object known as Oumuamua passed through our solar system in 2017, it didn't hang around for long. In fact, it moved so fast and so far that only the Hubble Space Telescope managed to observe it for just 11 days after Oumuamua's discovery on October 30th, 2017. A team from the Initiative for Interstellar Studies launched Project Lyra, a bold mission concept aimed at doing the unthinkable, sending a spacecraft to chase down this mysterious object and study it up close. But let's be honest, this isn't your average space mission. We're not talking about a quick hop to the moon or Mars. This is a high-speed, deep space pursuit that would cover billions of miles across some of the most extreme environments imaginable. Still, some experts think it's doable. One of them is Adam Hibbard, an engineer and key figure in Project Lyra. He's the brains behind a tool called OIT's Optimum Interplanetary Trajectory software, which helps design the most efficient flight paths through space. For Hibbard, this mission isn't just about solving the mystery of Oumuamua. It's about opening a new chapter in space exploration and possibly unlocking secrets about interstellar travel. Step 1. Build a spacecraft that can survive the brutal conditions of deep space. This isn't just about flying fast, it's about staying alive while doing it. The probe would need serious radiation shielding to protect its instruments from cosmic rays that could fry its systems long before reaching its target. And as for catching up to Oumuamua, that's where things get really interesting. We don't need massive engines or giant fuel tanks. Instead, we can borrow a trick from previous space missions' gravitational assists. Think of it like cosmic parkour. The spacecraft would slingshot around planets to gain speed, using their gravity to catapult it forward. Here's how the route could look. First, the probe launches from Earth and swings by Venus for its first speed boost. Then, it returns to Earth for another gravitational kick. After that, it heads toward Jupiter, where the gas giant gives it one final shove, fast enough to put it on a direct path to Oumuamua. But even that might not be enough. So scientists are also considering an even wilder plan called the Solar O-Berth Maneuver, a move so risky, it sounds like something out of a sci-fi movie. In this version, the probe first travels to Jupiter, then uses the planet's gravity to bend its path back toward the Sun. It would dive dangerously close, just enough to stay intact, then fire its engines right at the moment of closest approach. At that point, the Sun's massive gravity, combined with the rocket's thrust, would launch the probe away at incredible speed, possibly reaching up to 163,000 miles per hour. That's between 20 and 45 miles per second, the exact speed range needed to close the gap between us and Oumuamua. Of course, there's a major problem: the heat. Getting that close to the sun would mean temperatures soaring past 1,400 degrees.
But if we can pull it off,
We'd not only catch the first known visitor from another star, we might finally learn what it really is. Was it just a strange rock? Or was it something far more advanced? One thing's for sure: missions like this push the limits of what we can do, and maybe what we can discover about our place in the universe. We've actually done something like this before. Back in 2024, NASA's Parker Solar Probe broke records by flying just 3.7 million miles from the Sun, closer than any spacecraft in history. How did it survive that insane heat? With a specially designed carbon foam heat shield that shrugged off temperatures hotter than molten lava. And now, a similar shield is in the works for the new mission, the one aiming to catch Oumuamua. The design for the Oumuamua chasing probe already exists, at least as a 3D model, but scientists still haven't locked in the exact flight plan. Should the spacecraft perform a complex gravity assist dance around Venus, Earth, and Jupiter? Or should it go full throttle with a daring dive past the Sun for a massive speed boost? Some researchers are even considering more futuristic options. Imagine a spacecraft pushed through space by a powerful Earth-based laser, gaining speed without burning a drop of fuel. Or solar sails, ultra-light structures that use the pressure of sunlight to coast silently, steadily across the void. While these ideas sound like science fiction, they're real concepts in development. They're not quite ready for prime time yet, but they could redefine space travel in the coming decades. As for chasing down Oumuamua, current plans suggest a launch window sometime between 2030 and 2033. The most realistic trajectory right now? That gravity assist route. If all goes well, the probe could reach Oumuamua by the early 2050s, giving us a once-in-a-lifetime chance to examine something that may have traveled from another star system. But what if the plan doesn't work? What if the probe can't catch up? Or worse, what if it finds Oumuamua but flies past it too quickly to collect any meaningful data? Remember, Oumuamua is tiny, dark, and emits no light or signal. Spotting it in deep space is like trying to find a needle in an infinite haystack that's flying away at tens of thousands of miles per hour. There's another challenge. Even if we catch it, the spacecraft has to slow down just right. If it doesn't, it'll blow past Oumuamua. No photos, no scans, no second chances. Still, according to engineer Adam Hibbard, even if we miss the target, the mission won't be a failure. Why? Because this would be the first spacecraft intentionally sent to leave the solar system. And that's a huge deal. So far, only Voyager 1 and Voyager 2 have made it beyond the heliopause, the invisible boundary where the sun's influence fades and true interstellar space begins. But let's be honest, that was mostly luck. Those spacecrafts were built to study planets, not the vast unknown between the stars. This new probe, it's different. From day one, it's being built to go the distance to survive deep space, handle radiation, and send back data from beyond the edge of the solar system. Even if it never reaches Oumuamua, it'll still give us a window into what lies beyond the sun's reach, the kind of data humanity's never had before. And if we do catch up to Oumuamua, that could change everything. Right now, most scientists believe Oumuamua is a strange but natural object, maybe a dense asteroid or a metallic comet from another star system. But its odd shape, unpredictable acceleration, and lack of a comet tail don't fit the mold. So, what is it really? If our probe gets close enough, we might finally get answers, and maybe even a surprise no one saw coming. One thing's for sure, Oumuamua isn't your typical space rock. It's bone-dry, with no signs of water or ice, and its reddish tint likely comes from being bombarded by cosmic radiation for millions of years. Once scientists had a rough idea of what it was made of, the next big question naturally followed. Where in the universe did this thing come from? To get some answers, astronomers tried to rewind the clock. In 2018, they ran simulations to trace Oumuamua's path backward through space. What they found was stunning. Roughly 1 million years ago, this object passed near several stars, but it came closest to a faint red dwarf named HIP 3757. Could that be where its long journey began? Another theory suggests a different origin, the Vega system in the Lyra constellation, about 25 light-years away. So far, scientists haven't found any Earth-like planets around Vega, but that doesn't mean they're not there. It's not out of the question that some advanced civilization somewhere near Vega sent Oumuamua our way either by accident or on purpose. Now, as we speak, Oumuamua is barreling toward the constellation Pegasus, continuing its cryptic voyage through the galaxy. By late 2025, it's expected to reach the outer edge of the Kuiper Belt, a vast ring of icy objects beyond Neptune. Then, by November 2038, it'll cross the heliopause, the boundary where the sun's influence ends. Beyond that point, pure interstellar space. This mysterious visitor appeared without warning and vanished just as fast, leaving us with more questions than answers. But the scientific world isn't sitting still. Oumuamua's brief appearance was a wake-up call, and now
Enter the European Space Agency's
Comet Interceptor mission, a bold plan to catch the next interstellar object before it disappears. The tricky part, these objects travel so fast that by the time we spot them, it's usually too late to launch anything in time. So ESA is flipping the script. Instead of waiting, they'll launch a ready-to-go probe in 2029, positioning it at Lagrange point L2, about 930,000 miles from Earth, a cosmic sweet spot where gravity from the Earth, Moon, and Sun all balance out. It's the perfect location for a long-term stakeout. Once stationed, the probe will lie in wait, and the moment a new interstellar object shows up, it'll spring into action, deploying 2 nimble mini-satellites to surround the target and study it from multiple angles at once. Most astronomers still lean toward Oumuamua being a weird but natural object, maybe an unusually shaped comet or asteroid, but others aren't so sure. Some believe it could be a piece of alien technology drifting through space long after its creators vanished. Right now, we don't have the evidence to say either way. Oumuamua is already far beyond our reach, silent, dark, and fading fast. But next time, we might just be ready. Trying to chase down the truth in space might sound impossible, crazy expensive, risky, and let's be honest, completely over the top. But here's the thing. It's exactly those wild mysteries that spark our imagination. When something truly unknown flies past Earth, we have to ask, what was that thing? Should we go after it? Is it worth the cost? Back in 2017, Oumuamua streaked past us and vanished into the dark. What do you think it was? Should humanity really spend billions chasing objects like that? Drop your thoughts in the comments. We're curious what you think. But before we wrap things up, let's rewind to something we mentioned earlier, Oumuamua's bizarre shape. That brings us to another strange object, this one sitting out in the frozen edges of our solar system, Arakoth. It's one of many secrets hiding in the Kuiper Belt, a mysterious region beyond Neptune, filled with ancient leftovers from the birth of our solar system. Some of these Kuiper Belt objects are small, around 60 miles wide. Others are massive, over 600 miles across. These aren't just random rocks, they're like cosmic fossils, dating back 4.5 billion years. And we've only scratched the surface. About 2,000 have been officially catalogued, but there are likely millions. In April 2016, NASA's New Horizons probe, fresh off its historic flyby of Pluto, entered this icy realm and spotted something weird. It was moving oddly, definitely not your average frozen chunk of ice and rock. They named it Auron. In fact, it was spinning so quickly, about once every 5.5 hours, that if it were made of regular rock and ice, it should have torn itself apart. But it didn't. That raised a serious question. What in the world is this thing made of? NASA decided it was time to take a closer look. They adjusted New Horizons' course to fly past Auron. But just as it approached, something strange happened. The signal went dark. For a moment, New Horizons lost contact, like something was jamming its transmissions. Then, just as mysteriously, the connection returned. NASA later chalked it up to a computer glitch. Still, they missed the closest pass to Orion. And the object? It kept on spinning, disappearing back into the darkness. Some scientists have speculated off the record that maybe, just maybe, Orion isn't natural at all. One theory suggests its spinning might be creating artificial gravity, like something out of a sci-fi movie. Could it be a giant spacecraft, hiding in plain sight? We don't know yet. But one thing's for sure, space keeps throwing us curveballs, and with each one we're left with more questions than answers. Okay, here's a wild idea. What if there's something or someone hiding out in the cold, dark edges of our solar system? Let's talk about gravity first. Some of these mysterious Kuiper Belt objects are spinning fast enough to generate a little gravity, not enough for humans to stand on, but maybe, just maybe, enough for a very different kind of life form. Could one of these strange space rocks actually be some kind of alien ship, like Oumuamua, which many scientists have debated about? Honestly, probably not. But hey, there's always that tiny sliver of a chance. And if you were an alien species trying to quietly observe the strange, noisy creatures called humans, wouldn't a hidden outpost in the Kuiper Belt be the perfect place? Maybe one day we'll get another shot at flying close and finally figuring out what these bizarre objects really are, especially one in particular, Orion. But let's shift gears to something we have studied up close. Back in 2014, astronomers discovered another object out in the Kuiper Belt, a weirdly shaped little world about 20 miles wide. It looked like a cosmic snowman floating in space. Scientists were puzzled. How does something like that even form out there? They named it Arrokoth. And in 2019, NASA's New Horizons probe paid it a visit. That flyby made Arrokoth the farthest object in space we've ever examined, up close. In fact, it was spinning so quickly, about once every 5.5 hours, that if it were made of regular rock and ice, it should have torn itself apart. But it didn't. That raised a serious question. What in the world is this thing made of?
For a moment, New Horizons lost contact,
like something was jamming its transmissions. Then, just as mysteriously, the connection returned. NASA later chalked it up to a computer glitch. Still, they missed the closest pass to Orion. And the object? It kept on spinning, disappearing back into the darkness. Some scientists have speculated off the record that maybe, just maybe, Orion isn't natural at all. One theory suggests its spinning might be creating artificial gravity, like something out of a sci-fi movie. Could it be a giant spacecraft, hiding in plain sight? We don't know yet. But one thing's for sure, space keeps throwing us curveballs, and with each one, we're left with more questions than answers. Okay, here's a wild idea. What if there's something or someone hiding out in the cold, dark edges of our solar system? Let's talk about gravity first. Some of these mysterious Kuiper Belt objects are spinning fast enough to generate a little gravity. Not enough for humans to stand on, but maybe, just maybe, enough for a very different kind of life form. Could one of these strange space rocks actually be some kind of alien ship, like Oumuamua, which many scientists have debated about? Honestly, probably not. But hey, there's always that tiny sliver of a chance. And if you were an alien species trying to quietly observe the strange, noisy creatures called humans, wouldn't a hidden outpost in the Kuiper Belt be the perfect place? Maybe one day, we'll get another shot at flying close and finally figuring out what these bizarre objects really are, especially one in particular, Orion. But let's shift gears to something we have studied up close. Back in 2014, astronomers discovered another object out in the Kuiper Belt, a weirdly shaped little world, about 20 miles wide. It looked like a cosmic snowman floating in space. Scientists were puzzled. How does something like that even form out there? They named it Arrokoth, and in 2019, NASA's New Horizons probe paid it a visit. That flyby made Arrokoth the farthest object in space we've ever examined up close. You might think a frozen rock that far out wouldn't be very exciting, but for scientists, this was a huge deal. Why? Because Arakoth might be one of the most ancient and untouched objects in the entire solar system. Here's the big picture. Scientists believe our solar system formed from a massive cloud of dust and gas. Over time, gravity pulled all that material together to create the planets, moons, and asteroids we know today. But there's a huge blank spot in that timeline. We still don't fully understand how that cloud transformed into solid objects. That's where the Kuiper Belt and especially objects like Arakoth come in, because it's been preserved in deep freeze at minus 370 degrees.
Arakoth isn't just any rock, it's what scientists call
A contact binary, meaning it's actually two separate bodies stuck together. What's cool is that each lobe is slightly different in color, suggesting they formed separately and only later joined forces. But here's the mystery. How did they merge without blowing each other to pieces? Turns out, in the early solar system, collisions weren't always violent. These two chunks probably gently orbited each other, drawn together by gravity, until they touched just enough to stick, but not shatter. So yeah, it's not an alien spaceship, but it might be even better, a clue to how everything we see in space today, planets, moons, comets, actually formed. And who knows, the more we explore the Kuiper Belt, the more we might uncover even the unexpected. Every object out there in space has a story, a wild tale about how it came to be. And if you're curious about how our own sun and solar system were born, drop a comment and let us know. We might just make a video on that next. But back to the Kuiper Belt. Arakoth may be fascinating, but it's far from the only strange thing floating out there in the dark. Let's talk about another oddball. This one isn't famous for its looks or its size, which is around 650 kilometers across. It's not colorful, and it doesn't have an unusual shape. What does make it stand out? Its density, or lack of it. This mysterious object is so low density, it's actually 18% less dense than water. Yep, if you had a cosmic swimming pool big enough, it would float. Its name? 2002 UX-25. Not exactly catchy, but don't let that fool you. This thing is a puzzle wrapped in ice. Scientists are scratching their heads over how something so big can be so light. Usually, objects this size are packed tightly together by their own gravity. That squeezes out any gaps inside, making them denser. Low density is typically only seen in much smaller objects, under 350 kilometers. So how is this one defying the rules? Is UX-25 a quirky leftover from the solar system's early days, a strange exception, or something that could rewrite everything we thought we knew about how planets form? We need more data to crack the case, and that means learning a lot more about the average-size Kuiper Belt objects, not just the outliers. But wait, it gets even more interesting. Let's move on to a bigger and even weirder object. This one's called Quasar. Yeah, try saying that 5 times fast. It's nearly 1,300 kilometers wide, about 4 times bigger than UX-25, and it's got some serious history. Scientists think Quasar might have once been twice its current size. What happened to the missing half? One theory, it may have had a massive collision with Pluto, losing a huge chunk of its material in the process. But that's just the beginning of the mystery. Here's the part that really stuns researchers. Quasar seems to have warmed up by over 100 degrees Fahrenheit. Long ago, its surface temperature rose from minus 360 degrees Fahrenheit to around minus 260 degrees Fahrenheit. That's a big jump in the frozen outer solar system. The big question is, how? Did it get hit by something, or was it heated up artificially? Could someone or something have been responsible? Adding to the intrigue, scientists have found water ice on Quasar's surface, and there are hints it might have once had a subsurface ocean, meaning this icy world might have been more dynamic than we ever expected. And get this, the surface of Quasar is surprisingly bright. That might be a clue that there's been geological activity, like cryovolcanoes. If you've never heard of those, think of regular volcanoes but way colder. Instead of spewing lava and ash, cryovolcanoes erupt ice, methane, ammonia, and other frigid materials. It would be a jaw-dropping sight, like an alien snowstorm. blasting from the surface. No missions to Quaoar are on the books yet, but if one ever gets the green light, you better believe we'll be talking about it. And finally, let's step even farther out beyond the Kuiper Belt. There's another space oddity worth mentioning. When astronomers spotted this one, it instantly raised red flags because something about it just didn't fit. We typically expect distant objects to be made of ice, right? So they're usually white or gray, but not this one. This object is deep red, almost as red as Mars. Even stranger, its movement through space is unusual. It doesn't follow the clean, predictable orbits we're used to seeing. What is this thing? Where did it come from? And why is it defying expectations? These are the kinds of questions that keep astronomers up at night and that push our exploration even deeper into the unknown. Imagine an object so far from the Sun, it takes 11,000 years just to complete one orbit. That's Sedna, and it doesn't behave like anything else in our solar system. At its closest, Sedna swings in to about 11 billion kilometers from the Sun, then drifts way out to around 135 billion kilometers. It's like it's playing a game of cosmic hide-and-seek, and no other object we've seen moves quite like it. So, what's going on? Well, Sedna isn't drifting alone. It seems to be part of a group of far-off objects whose orbits are being shaped by some kind of shared gravitational force, something scientists can't fully explain yet. It's kind of like a silent dance happening at the edge of the solar system, with all the dancers tugging and pulling on each other. Now here's where it gets wild. Some researchers think this strange orbit might be part of a much bigger story, one that possibly connects to a mass extinction on Earth. The idea is that when objects like Sedna swing close, they might knock comets loose, flinging them toward the inner solar system and maybe even toward Earth. It's a long-shot theory, but still within the realm of possibility. But there's something else. Sedna's strange path suggests there's a mysterious force pulling on it from even farther away. And that force? It might be the long-rumored planet 9. This hypothetical planet is thought to be 5 to 6 times the size of Earth. Huge, cold, and lurking beyond the Kuiper Belt. Some scientists believe it could actually be an interstellar object that wandered into our solar system from another star. Others think it might be something far stranger, like a tiny ancient black hole. Whatever it is, we haven't found it yet. But if Planet 9 really exists, it's hiding behind a bright band of stars in the Milky Way, making it tough to spot. Still, recent studies hint it might be closer and brighter than we originally thought, which means we might finally have a shot at seeing it. That's where the Vera Rubin Observatory comes in. With its massive 8.4-meter telescope, it's designed to scan a huge portion of the night sky over and over again. Once it's fully operational, it might just catch a glimpse of Planet 9. And if it does, it would be the first new planet discovered in our solar system in over 200 years. Now let's talk about some of the other big players way out there beyond Neptune. Take Makemake, one of the largest known objects in the Kuiper Belt. It's the 25th biggest body in our solar system, and after Pluto, it's the brightest thing out there. Fun fact, Makemake was one of the reasons Pluto got demoted to a dwarf planet. When scientists found something that big, they realized there were probably a lot of similar objects floating out there, which meant Pluto wasn't so special after all. But Makemake isn't just big, it's weird. It has a moon, called MK2, and while Makemake shines bright, MK2 is pitch black, like a lump of coal. No one really knows why. Scientists also expected Makemake to have a thin atmosphere, but surprise, it doesn't. And it's cold, like minus 400 degrees Fahrenheit cold. At that temperature, life as we know it is completely off the table. Despite all this mystery, there are no missions currently planned to visit Makemake. But it's not the only oddball out there. Let's look at Haumea, another dwarf planet, and this one's even stranger. First, Haumea is shaped kind of like a squashed football, spinning so fast it's stretched itself out. It has 2 moons, a weird rotation, and most bizarre of all, it's the most distant known object in space with rings. Yep, rings, like Saturn, but way farther out. Haumea orbits the Sun way beyond Pluto, yet it's still the 3rd closest dwarf planet to our star. That tells you just how vast and remote the outer solar system really is. So what's waiting for us out there? More questions, more discoveries, and maybe, just maybe, a planet we've never seen before that could change everything we think we know about the edges of our solar system. If you're into deep space mysteries, this is just the beginning. Way out past Neptune, there's a bizarre, fast-spinning object that looks like a squashed football, or maybe a rugby ball. This is Haumea, one of the strangest dwarf planets we've found in the Kuiper belt. Picture throwing a water balloon and watching it stretch and wobble as it spins. That's kind of what happened to Haumea. As it rotated rapidly through space, its shape warped into this elongated, flattened form. And we're not talking slow rotation. Haumea spins fast. One full day on Haumea lasts just 3.9 Earth hours, making it one of the fastest rotators in the entire solar system. If you somehow lived there, your day would be over before breakfast. And get this, if you measured your age in Haumean years, you'd be about 283 Earth years old. But Haumea's weirdness doesn't stop with its shape or spin. While the core is mostly rock, its outer layer seems to be coated in ice, just like the frosty buildup in your freezer, only colder, way colder. And then there's the red spot, a strange, rusty patch on its surface that scientists think could be rich in minerals. But honestly, no one really knows what it is yet. It could be something totally unexpected, maybe even something not natural at all. That's where things start to get interesting. Because in space, the more we discover, the more we realize how much we don't know. And that mystery fuels ideas that might have sounded like science fiction not long ago, like the possibility that we might stumble across signs of alien technology. Enter the Galileo project, launched in 2021. Its goal? To search for hard evidence of extraterrestrial artifacts, both out in space and right here on Earth. The odds of finding alien tech might be low, but even a small chance could lead to one of the biggest breakthroughs in human history. Even if the project doesn't uncover flying saucers or alien probes, it still might help explain some of the biggest space mysteries we've come across, like the puzzling interstellar visitor Oumuamua, or those strange objects sometimes caught on military radar. And here's the best part, the Galileo team has promised to make all of its findings public. No cover-ups, no secrets. If they find something, we'll all get to see it. So keep your eyes on the sky and your news feed, because the next big discovery